The eruption is the most serious threat posed by a volcano in Iceland in half a century.
Stop the lava from getting into their community, but we know that that has not stopped that from happening. That lava already destroying some of the homes.
Iceland is an island nation sitting in the middle of the North Atlantic Ocean. Here, fire dances with ice, showcasing the breathtaking spectacle of active volcanoes, colossal glaciers, cascading waterfalls, rugged peaks, black sand beaches, spectacular lava, and beautiful but dangerous landscapes. A recent earth-shattering event has sent thousands fleeing from their once peaceful homes. But what mysterious occurrence has recently taken place in Iceland that suddenly disrupted in Iceland that has caused thousands to flee their homes and left scientists deeply unsettled? And how does Iceland's unique combination of active volcanoes and massive glaciers contribute to the recent earth-shattering event that has sent shockwaves throughout the nation and across all of Europe? Join us on this gripping journey as we unravel what just emerged in Iceland that terrifies scientists. Iceland and volcanoes. Throughout history, Iceland has borne witness to formidable volcanic eruptions that have permanently transformed the country's landscape. Most notable is the powerful eruption of Eyjafjallajökull that occurred in 2010. The eruption of this famous volcano was a turning point in Iceland's history, as it unleashed chaos across Europe. Its effects were staggering, as massive ash clouds wrought havoc, and air travel was paralyzed for weeks. This unprecedented disruption captured worldwide interest, impacting millions of European travelers and wielding a substantial influence on Iceland's economic landscape. Hekla stands as one of Iceland's most active volcanoes, having experienced over 20 eruptions in and around it since 1210. Its most massive volcano reached a staggering height of 4,898 feet. In the Middle Ages, the Icelandic Norse referred to the Hekla volcano as the gateway to hell. Katla, another of Iceland's highly active volcanoes, resides beneath the Mýrdalsjökull glacier. Among the country's 32 active volcanoes, Katla receives the utmost attention. Being one of the largest and most dreaded volcanoes, Katla lies beneath thick glacial ice, posing the risk of extensive flooding when it erupts. Its last eruption occurred in 1918. But it has gained renewed attention in recent years due to the horrifying Netflix series Katla, primarily filmed around Vik. Then there's Grímsvötn, Iceland's volcano that erupts most often, concealed beneath the Vatnajökull glacier. Its eruption in 2011 led to air travel disturbances in northwestern Europe from May 22nd to 25th, 2011. Grímsvötn had previously erupted in 2004. Interestingly, experts have found that these volcanoes do not merely cause disruptions, they also contribute positively. Their geothermal energy serves as a significant source of power and heat for Iceland, illuminating households, fueling industries, and providing warmth to places like the famous geothermal spa and the Blue Lagoon. They are equally significant to the island's narratives. Stories and legends influenced by these fiery peaks are carefully connected with Icelandic history. Iceland continues to experience such intense volcanic activity due to its unique geological position. The country resides at the intersection of distinct geological forces, the spreading plate boundary along the mid-Atlantic Ocean ridge, and a robust mantle plume generating a hot spot on the surface. These combined forces generate substantial magma, filling gaps in the crust caused by the spreading plates and leading to frequent eruptions along the rift zone. Experts have warned that these eruptions would not only disrupt air travel as it's been a common occurrence in the past, it'll also impact the climate and even influence global weather patterns. Consequently, scientists are carefully observing these volcanoes, conducting daily monitoring to understand their behavior and anticipate potential eruptions, while giving priority to the safety of Icelanders and others. Iceland's connection with its volcanoes is intricate yet conventional, but recent discoveries have transformed the known narrative, presenting it in a new light. Man-made caves. A man-made cave system discovered near the small town of Adi in Rangárvallir during a routine excavation by the Archaeological Institute of Iceland in 2018 has significantly changed our understanding of this island nation. This extensive cave network is believed to date back to 800 to 1060 AD, aligning with the Viking Age when Iceland was initially settled. This revelation has sparked considerable interest, especially among historians, as these caves offer a unique glimpse into the lives of early inhabitants. Identified as Hellir, ancient Norse structures possibly utilized as stables, these caves' scale and intricacy imply they held a significance beyond mere structures. They likely played a crucial role in the community's survival within Iceland's harsh landscape. The discovery of this site validates the 13th century account found in Bishop Orlkur's Legends of Saints, depicting a cave's collapse with 12 bulls trapped inside. This discovery emphasizes the historical importance of the newfound location. What was initially thought to be merely a shelter has revealed itself to be a Viking settlement. Ongoing exploration indicates that this cave served multiple purposes. It functioned not only as a hiding place, but also as a storage facility for tools, weapons, and various artifacts, all contributing to our understanding of the Viking era. Throughout Iceland, Viking weaponry provides clues about the prominence of warfare and defense in their society. A deeper examination revealed the remarkable craftsmanship of these Vikings. Members of the archaeological team, upon witnessing the cave system, expressed their shock at its size and complexity. Initially hoping to see human or animal remains shedding light on daily life, the discovery exceeded expectations. This discovery offers a doorway to an entire community's historical narrative. Yet, this discovery extends beyond mere historical curiosity. Scientists have taken a keen interest in them, exploring various theories and contemplating the broader implications of this finding. It has led to inquiries into how many similar structures might lay hidden beneath Iceland's surface, awaiting discovery. Experts have been able to gather a lot of insights from these caves regarding the lifestyles of early Icelandic settlers and their ability to construct such complex formations with the limited technology of that era. Although fascinating, scientists have warned about the potential risks associated with these ancient caves. Due to their age, these untouched structures might be unstable, with the potential to collapse due to natural erosion or seismic activity. They could also potentially harbor old diseases or contaminants, posing risks to the surrounding environment. Moreover, there's a chance that these caves contain dangerous materials from the Viking era, potentially endangering the health of explorers. Experts strongly advise cautious exploration to safeguard both Viking artifacts and the well-being of those involved. Icelandia. A group of geologists has proposed a theory suggesting the existence of a landmass called Icelandia hidden under Iceland. This theory implies that the island nation might be a prospective continent stretching from Greenland towards Europe. If proven, this notion of a submerged continent could fundamentally alter the geological understanding of the entire North Atlantic region, prompting a significant revision of Earth's history. The concept of Icelandia raises questions about our comprehension of Earth's geological past, notably challenging the established belief regarding the breakup of the supercontinent Pangaea, which is generally thought to have occurred over 50 million years ago. This theory is based on the assumption that beneath Iceland lies a continental crust rather than solely an oceanic one, further hinting at untapped reservoirs of minerals, fuels, and resources. Yet, skeptics argue that validating such an assertion requires more substantial evidence. They stress the necessity for additional seismic studies and deep-sea drilling to validate the existence of a continental crust in this area. Geophysicists are captivated by the potential discovery of fresh mineral and hydrocarbon resources, foreseeing economic opportunities. However, this prospect also raises significant concerns as aggressive mining and drilling endeavors could severely disrupt marine ecosystems in the area. Moreover, such activities might intensify resource exploration in a region already grappling with the impacts of climate change. Experts warn that any disturbance to the already delicate ecological balance could yield unforeseen consequences locally and globally. Still, these discoveries provide valuable insights, paving the way for further research into Iceland's Viking heritage and geological features. Conversely, geologists stress the need for comprehensive geological studies and environmentally conscious practices to balance exploration with environmental preservation. This might further strengthen the Icelandia theory. The recent geological discoveries pose a situation involving ecological, environmental, and geological consequences, necessitating thorough analysis and predictions. The uncovering of Viking-era caves near Oddi raises fears regarding geological stability. Additionally, the potential existence of Icelandia, the continent suggested to have emerged beneath Iceland, has the potential to significantly reshape our comprehension of the Earth's geological past if validated. These discoveries hold the potential for irreversible ecological damage if further explored. That is especially worrisome considering the potential existence of Icelandia and its potential global impact on weather patterns. Scientists have expressed their concerns about the potential influence of Icelandia on the North Atlantic Oscillation, a key determinant of weather conditions in Europe and North America. Such alterations might disrupt established climate patterns, resulting in unexpected weather irregularities. From a geological standpoint, this discovery necessitates extensive research and surveys that could yield groundbreaking insights into continental drift and plate tectonics. A deeper understanding of the distribution of continental and oceanic crusts in the North Atlantic area is crucial for accurately predicting volcanic activities and earthquake risks. The theoretical existence of Icelandia challenges established geological theories, prompting a re-evaluation of our understanding of the Earth's formation and processes. This could trigger discoveries and theories in geology that extend far beyond the North Atlantic region. While the discoveries in Iceland are fascinating, they bring along a spectrum of ecological, environmental, and geological concerns that demand careful consideration. Exploring the new discoveries. As research progresses, it becomes increasingly clear that we must strike a balance between the thrill of discovery and the responsibility to protect our planet's fragile ecosystems and rich historical legacy. These discoveries stand as captivating insights that shed light on past geological events, shaping Iceland's terrain and contributing to scientific knowledge. The recent geological findings in Iceland highlight Earth's dynamic geological processes and emphasize the crucial necessity of closely studying and monitoring its geothermal activities. These discoveries have encouraged a comprehensive initiative involving continuous monitoring, emergency readiness, global collaboration, climate impact research, and sustainable tourism practices in Iceland. Such measures are imperative for safeguarding communities, advancing scientific understanding, and preserving Iceland's distinct geological heritage. Faced with Iceland's ever-changing geology, scientists have taken proactive steps to comprehend and mitigate potential risks, ensuring preparedness against any unexpected geological occurrences. Previous events, such as the significant impact of the Eyjafjallajökull eruption, have led to advancements in monitoring systems and preparedness measures. This has contributed to a broader narrative of global environmental and geological transformations. The discoveries in Iceland serve as a sharp reminder of Earth's interconnected geology. They demonstrate how changes in one geographical region offer invaluable insights into the planet's historical and future trajectory. The revelation of Icelandia poses a challenge to established theories regarding continental drift and the planet's overall climate system. Comprehending these mechanisms, particularly in geologically active zones like Iceland, holds immense importance for forecasting future climate trends. For context, volcanic eruptions, while releasing substantial amounts of greenhouse gases, can also induce a cooling effect on Earth by reflecting sunlight away from its surface. Additionally, the revelation of these new geological aspects in Iceland promises to offer valuable insights into the planet's historical climate conditions, potentially impacting the globe. Amidst the challenges posed by climate change, the knowledge gained from Iceland's ever-changing geology undeniably contributes to our global endeavors in comprehending and safeguarding our planet. In response to these remarkable geological discoveries, Icelandic authorities and the global scientific community have implemented proactive measures. These measures aim to monitor, comprehend, and minimize potential risks resulting from Iceland's dynamic geology. To achieve this, techniques such as satellite imagery and aerial surveillance are employed to monitor alterations in the landscape, such as the emergence of new volcanic fissures or shifts in tectonic plates. Additionally, the presence of warm ocean currents surrounding Iceland amplifies the region's climate impact. The North Atlantic Oscillation, NAO, a climatic phenomenon, is closely linked to pressure differentials between the Icelandic low and the Azores high. These pressure systems are interconnected with temperature differences arising from the meeting of warm and cold ocean currents encircling Iceland. Alterations in the NAO have wide-reaching effects across the northern hemisphere, shaping weather patterns from winter temperatures to precipitation levels. Iceland's geological discoveries offer scientists a natural setting to examine the intricate processes of the Earth. With its wealth of volcanic activity, including active volcanoes, geysers, and hot springs, Iceland stands as an excellent site for studying tectonic plate shifts, seismic events, and volcanic outbreaks. This information significantly enriches our overall understanding of Earth's geological mechanisms. And apart from deciphering historical and current events, delving into Iceland's geology provides glimpses into potential future scenarios. With its status as a geothermal energy hub, Iceland's importance expands in a world increasingly prioritizing alternative, sustainable energy sources. The volcanic eruptions serve as a reminder of nature's immense power, showcasing both human vulnerability and resourcefulness. The geological activity within the country has further highlighted the dangers of residing in active areas, initiating discussions about reducing risks and being prepared. This research holds significant importance in understanding the impact of volcanic activity on climate systems. Similarly, there is a notable emphasis on promoting sustainable and responsible tourism in light of these geological phenomena. As Iceland's unique landscapes attract a growing number of visitors from all over Europe, authorities are diligently working to ensure that tourism activities do not adversely affect these delicate geological sites. This effort includes restricting or regulating access to specific areas, advocating for eco-friendly tourism practices, and educating tourists about the importance of preserving these natural wonders. The reaction to Iceland's recent geological discoveries comprises a comprehensive initiative involving continuous monitoring, readiness for emergencies, international collaboration, research on climate impacts, and the promotion of sustainable tourism practices. These initiatives play a crucial role in protecting communities, advancing scientific knowledge, and conserving Iceland's distinctive geological heritage. How will these discoveries affect the history and survival of Iceland and surrounding European countries? Let us know your thoughts in the comments section.